Hi everyone. We had a few questions today about this question in your exam. So this is an axonometric question from the 2016 Leaving Cert higher level paper. It was one of the short questions, question 4. And what this is a reverse engineered axonometric question. So you're given the axonometric view and you're given the plan. And what we need to find out is the elevation. So when you're drawing the axonometric view, we take our heights from elevation, but we can't do that. So we're going to work backwards. We're going to bring all of our points back to plan and bring all of our heights from elevation. So that's what I'm going to do here. We have some of our lines already drawn in, so we have a nice base to start from. So we have 1, 2, 3 points done, and I'm just going to bring down the rest. 2 of these points correspond with this center, so that's perfect. Okay, we have a few similar points here, so these 2 points are going to be the same as this, and these 2 are the same as this one here. What this is we're looking at this cube as if it was inclined up the way, as we can see, but this is going to be a plan, and for our elevation we're going to be looking in from this direction. So this kind of threw a few people off looking in from this direction, but I'll try and explain a bit better on how to do it. So now that we have our points brought back to our plan, what we need to do next is just do some light lines into elevation. So we don't know how tall it's going to be yet, so what we're going to do is just bring them up a good bit. These are all light lines, by the way. I'm doing them a little bit heavier because we struggled to see them in the video yesterday. Okay, now all I have to do, take my compass and go to the corresponding point. So I'll start here, follow this point down, it's here, take your height and mark it off. Do this for each of your points. So this height is going to be used both here, and if we keep following this line through, it's going to be the same for this point. Now this height's at 0, we already have that. Move on to the top of the shape, follow it back, it's in the center. 2 more heights. Again, this height is going to correspond with 2 points. So we have 1 and we have it again. So we don't need to do that one. And our last point, follow it back, bring it up. So we should have all of our points here. Now what we need to do is draw this as we're looking at it from the front. So we're going to have roughly a face here, face up the top here, and kind of a skewed face out here. So what I want to do is find where these points are going to connect. So this point, the center, connects out to this point. We'll draw this. Center also connects to here. We'll draw this one. And this point connects here, so we can connect them. There's one face done. So now this point, follow it down, connects to here at the front. This point. At this point, joins to here, follow it up, these 2. Now finally, this point goes back to the center at the top, not the bottom this time. So we're going to go up to the taller height and connect them together. Finally, you can probably see where this is going. This point connects back to the center at the top, so follow it up. Now all I want to do is find the hidden detail in this shape. So I need to find this back point. So for this height, should probably already have it in. Just here. So I can join up my hidden detail into this point. Okay. So just so you might be able to see it a little bit better, I'm going to fine line over lines. So this is the reason why knowing the process to a question is so important. If you're given a question where you have to find, say, your plan or elevation, but you're given the finished product, you need to know how we get the finished product in order to get the start. So what we're doing here is just reverse engineering the question to find, say, our starting point, the elevation. So knowing how to do it forwards isn't enough. We need to know the process behind the question and the reason why. So this is part A done. Now, part A is done. Part 2 says draw the plan and elevation of the smallest possible sphere that will contain the cube. So when it says can contain the cube, it means it's going to be outside the cube. So what this is circumscribing a circle around the cube. So what we need to do is join the furthest out points and the lowest and highest point. Doing this will get us the circumcenter. What we're going to do with this, put our pin in the circumcenter and move it up to our highest point. Just see that it touches each of our points. It does, so I'd be happy with this. We can go ahead and circumscribe a circle around the cube. Okay, it's a little bit messy, but you get the gist. So that's going to be our point O, and this is the circle going around. Now, keep your compass at the same distance. We're going to do the same down here. Now, you can see that the circle touches each of the points in plan and elevation. So that's how we do that question on your exam, the short question from 2016 Leaving Cert Higher Level.